Hi there, it's Richard Little joining you again from your land partner. We are on video 77 of 100. We are in the build phase, the bit that I get excited about, and so do a lot of people. But we're still in the paperwork bit in terms of the videos. We're still in the pre-construction phase of that, and we're talking about a number of the consultants. And today we're going to be talking about the civil structural engineers and what role they are and how important they are, etc. Civil engineers, structural. I'll give you the difference first. Really, a structural engineer is slightly more specialism in the area of civil engineering. So they're not the same, but they are the same. So it will come under the same practice that you'll go to. You'll go to an engineering practice, civil engineering practice, and they'll have structural engineer capability within the practice. So what are the interests? It's basically infrastructure. So to start with, so it's anything that sort of the roads. If you've got bridges and things like that. But on sort of projects that we do somewhat smaller, so it's down to roads, sewers, drainage, etc. Also other stuff underground, so anything underground, so foundations, foundation design and specification, etc. So they're taking the reports, so we'll have site investigations done, etc., and they'll take all the results from the reports and turn them into a detailed design, detailed specification for all of those, so the drainage, the roads, foundations, etc. And obviously this is key because, one of the things that we don't know about a new build project is underground. So what we're looking at is getting as much information, so as much testing as we can, so that any design work that is done through the pre-construction phase is going to be accurate. So what I want to do is give you an example. What I'm going to do is give you an example where it could go wrong. Drainage is quite rightly, a massive thing these days. And part of most planning applications, I won't say all because I'm sure there's some that aren't, but most planning applications is part of that paperwork is a drainage strategy. Now, a strategy is pretty much how are we going to meet what we need to meet in terms of this particular project from a drainage point of view. So that can be the two types of drainage, which is foul drainage and storm drainage, so rainwater and all the other stuff. So the strategy is effectively, it's a theory. It could be based on maybe some tests, maybe not necessarily tests. It could be based on the expectation of the geology in the area, and might have done works in that area previously, so they may base it on that. So we have a project that's on at the moment. We inherited much of the design work, a drainage strategy, and it was a good strategy. It read well, 48 pages or whatever, something like that, and it got planning consent because the planners examine it and all that sort of thing. Yeah, this will work. But what it didn't do, and this is where you've got to be really, really wary, especially if you are purchasing sites, acquiring sites that have already got planning consent, is don't think that the box is ticked because there is an approved drainage strategy. Because very often, and I mean very often, I won't say more times than not, because in our experience probably not, half and half probably, there or thereabouts, but quite a high percentage, it won't work when it gets on site. It's going to be subject to a lot more ground tests, a lot more soil tests. They're looking for the strength of the ground from a foundation point of view. They're looking at the ability of the ground to soak up water and drain water away, obviously for the drainage strategy. And what can actually happen is this can be a massive difference, because part of a modern day drainage strategy, for instance, would be, and you've probably seen this, is what we call swales. They do have other terms as well, but they're dry ponds, if you like. So they're great big holes, if you like, in the ground, landscape to an extent, and you'll see them on most big sites and some smaller sites, depending on what part of the country you are. And that's part of the drainage strategy. That's to take the storm drain. That's to take the storm water in excess periods of rain. Yeah, that's what that's for. Now, that's designed to be a certain size, to take a certain capacity. Now, if the tests that they've used don't actually exist, they've just gone on modelling or something like that, just sort of, something that they've plucked out from somewhere out of a textbook, which there are lots of things that come out of textbooks in these drainage strategies. Excuse me. Then that hole, let's call it a hole, a swale, that hole, sorry, I'll say swale, that swale could need to be twice as big as it is. And if you've seen some of the sizes of them, they're pretty damn big. We've got one on a relatively small project of 10 units. It's pretty big. There isn't room to make it any bigger. It is as big as we can get it. So if that drainage strategy wasn't correct, we'd be stuck. We could end up losing a house, and on a 10-unit project, that's 10% of our houses are gone, and that's massive, in terms of margin, etc. So the point about this is really, say, we're talking about the civil engineering side, how important it is to have, some good civil engineers, good civil engineering practice, multidiscipline within civil engineering, so that they do cover things like structural engineer, which is covering, perhaps opening sizes, what's the roof out, what the floor beams, how big do they need to be, how big are the openings, what sort of beams go over openings, what is the roof makeup going to be. So the structural engineer is more focused on that sort of stuff, and also calculations of different types of structures. So if it's a timber frame structure, for instance, they're going to be calculating the structural strength and capabilities of certain types of timber. How big does that timber need to be? So it's all part of the same thing in this respect. So you're trying to look for a practice that possibly isn't a one-person band, whereas it can work, and as long as they've got, and they often will have, is somebody else that helps them out with certain other things. But what you don't really want, in my view, is what my dad would have called a jack of all trades. So somebody that does all the bits of civil engineering, but don't necessarily specialise in any of them. So yeah, perfectly capable for some types of jobs, but there is so much on this. There's so much risk on what the civil engineers say in terms, once we get to the detail. As I say, we've talked about planning consent and how planning consent can actually be given, but actually it's not then deliverable, and this is one of the real key areas. So again, on a project that we're working on, the road makeup, etc., and this is, you've got your civil engineer, and all this work's going to be checked out by another civil engineer on the the authority, whatever authority it might be. In this case, it's a county council or highways authority, and they're checking it all out, and they don't always agree. So the other thing, when you are engaging any professional, to be fair, but certainly we're talking about civil engineers today, is you want them to actually be able to talk to other engineers, and you don't want to get caught in between where somebody says, well, I'm right and they're wrong, and that's the end of it, because you get stuck in the middle. So you need somebody that is actually has the ability to reach out to other peers of their own, working for a local authority or a regional authority or whatever, to actually enter into dialogue with them and have a proper conversation. Because, this is based on science, if you like. These are the people that use calculations and algebra. All those of you that went to school and thought, what's the use of algebra? Well, actually, yeah, civil engineering and structural engineering use it all the time. Anyway, so it's all computerised now, so yeah, it's obviously a lot easier than when I was at school. But, it's really important to engage with the right people. And as with any other of your consultants, you want somebody to manage them. So again, we'll come back to, how effectively the project management through pre-construction is. This is where that something can be designed. So there's another area here where somebody can design something. And we've had first-hand experience of this quite a few times over the years, where somebody's come up with a nice design and it gets to the structural guys or the civil guys and they say, we can't build that. If we build it, it won't look like that. So again, depending on what you're doing, these guys should be really involved quite early on in your scheme, not waiting till the first they hear of you shouldn't be at pre-construction. You will generally be dialoguing with them if you're taking it through planning, an absolute key part of planning. Unless you're taking planning and you're doing outline and you're not doing any of this stuff, it becomes a reserve matter. And then the first you know about all of this stuff is when you engage with civil engineers and you start looking at a site in detail, and they'll start saying, well, actually, I don't think you can put those houses there. You know, this is how fundamental it is to design. So they are a key part of your design team. And certainly in pre-construction, you know, the detail that they provide you. So if you are providing, say, a structural engineer or the civil engineer, stroke structural engineer is designing a foundation. Now, if they design it, if they actually design it and let the computer software design it, then that generally is what we would say over-engineered. So what you want are engineers that are quite prepared to get the calculators out and actually say, oh, that beam doesn't need to be 600 by 600, it could be 600 by 450 in terms of section. Well, that's actually going to save a quarter of materials. 25% in that particular element. So it can be fundamental, it can be really important that they have the ability to actually engineer things. As I say, we don't want to skimp. So they're not going to design something and put forward a detail where, you know, their insurance basically isn't going to cover them. But actually, if you take standard software programs, and there are quite a lot of these in beam design and stuff like this, where it'll come out, and even I, in my relatively basic knowledge, can design a simple beam with a loading on it that is actually not as costly as you will get out of a standard software program, you know, and again, if you were looking at just beams and lintels, which are the supports that go over openings in buildings, you know, if you're in a standard house, you probably get to have 10 or a dozen of those, something like that. Well, actually, you know, you could potentially save 10%. Well, actually, it might not seem a great deal. It might be a couple of £100, but actually, take that, multiply that by 10, all of a sudden it's £2,000, and the engineer is more than paid for their fee. So we're not always saying that they're always going to have to do everything longhand, but when you're in certain situations, we want our engineers to have the ability to be able to get their pencil, paper, slide rule, probably not so much now, but, you know, get their tables out and actually calculate something, you know. And we've had experience of both, the ones that take the easy way and the ones that actually you know, will go that extra mile. So I think the purpose of what I'm trying to say mostly here is civil engineering is a massive part of you know, most residential projects and most commercial projects as well, and people don't always realise that. They think that whoever's designing it is going to come up with all of that. Well, actually, no, it's very much a specialist area. And as I say, these days with the importance of drainage, you can't get through any scheme without the input of a civil engineer, or you shouldn't be looking at doing it without a civil engineer. So hopefully that's given you a flavour of where civil engineering and structural engineering comes into play in terms of the sort of size projects that we do, mostly residential, a little bit of commercial, etc. And they are absolutely part of a key part of your team. And through the pre-construction phase, you need to get them going so that they're going to come out with a detailed design that's actually then going to go out to tendering or whatever process you're going to use in order to get any accurate prices. So it's been Richard Little from Your Land Partner on video 77. So we've been talking about civil engineers, structural engineers, and I hope that's been useful for you. As ever, if anybody's got any queries or comments, they can either put it in the thing underneath wherever you're watching it, whether it's Facebook, YouTube or whatever, and we'll endeavour to answer any queries as much as we can, or point you into the direction of the other videos that we've done and the other videos that we are still to do. So hopefully that's been useful. Enjoy the rest of your day. Take care.